This video is going to be on vacuum testing. So the vacuum testing is actually described pretty well on pages 311, 312 of your textbook. And if you notice in the background, I've got up on the projector up here, I've got that 312 page displayed. So the results of the vacuum test, this is a really good reference to have to know what you're looking at. But we're going to go over vacuum testing now. Okay, to do a vacuum test, first thing you're going to need is a vacuum gauge. And what I'm going to use, I'm just going to use this little vacuum pump, which has a vacuum gauge on it. Works just fine. If you have a separate vacuum gauge, that'd be great too. You can use that. The next thing you need to do is you need to find a manifold vacuum source. Now, manifold vacuum source just means that you've got air sucking when the engine is running. And so, easy way to figure that out is start the engine up and pull a vacuum hose off. If you can feel it suction, if you can feel the suction there, that's a manifold vacuum source. For this engine, it's real simple because we've got a port right here on the intake manifold that's a manifold vacuum source. So what I'm going to do is I'm going to go ahead and I'm going to hook up my vacuum gauge to that port right now. And then I'll start the engine up and we'll take a look at the reading and see what it is. So right now we've got, it's reading 0. So let me start the engine. And we're reading at about 20 inches of vacuum. One of the things that I want you to do with a vacuum test is watch what happens when you accelerate. When you snap accelerate, it goes down to almost 5 inches of vacuum and then it comes back up to 20. If I accelerate and then hold it there, notice when I first accelerated it dropped down to about 10, then it came right back up to 20. And then when I let go of it, it goes above 20 just a little bit. And that's basically what you're looking at when you're doing a vacuum test. With a vacuum test, at atmospheric or at sea level, you should see right around 20 inches of vacuum. That's typically what you'll see on an engine. The higher up you go in altitude, the less vacuum you'll see. Like for instance, when I worked at a Jeep Eagle dealership in Provo, Utah, just outside of Salt Lake, the most we ever saw was about 17 inches of vacuum. And because we were about 6,000 feet above sea level. Here we're about 200 feet above sea level here at the college. And so it's very common to see 20 inches of vacuum. When you accelerate, the pressure equalizes inside of the intake manifold right here. And for just a minute, it equalizes, and then the pressure less than atmospheric builds back up again. That's why when you first accelerate, you see a drop in vacuum and then it comes back up. And if you have a plugged up exhaust, when you accelerate and you stay accelerated, it'll come up to 20 and then it'll start gradually falling off because the engine can't exhale. So it doesn't build a vacuum in the gauge or in the manifold. So one of the ways you can tell if you've got a restricted tailpipe is just with a simple vacuum gauge right here. And if you look at on page 311 and 312 in your textbook, it shows multiple different scenarios with what vacuum will do with burnt valves, with a spark plug that's misfiring, all kinds of different things you can look at with engine vacuum. One of the things I want to do right now is try to explain the difference between ported vacuum and manifold vacuum. So if we look at the venturi, which is where all of the air comes into the engine, and typically it's kind of an hourglass shape, and you've got your butterfly throttle valve right there. So I pointed that out in another video where your throttle, that valve that opens and closes that meters the amount of air coming into the engine, that's the throttle valve right there. Now, if I was to have a vacuum port right here, Okay, that's underneath the manifold vacuum, or the throttle plates. So basically, you have air coming in this direction when the throttle plate is open. So if we have the throttle plate cracked open a little bit, then air is going to come in. It's going to kind of go around this area here. Now, if you notice, there's a restriction right there. If you turn that sideways, you might recognize the shape. If we go turn it sideways and go like this, that looks almost like an airplane wing. So what happens with an airplane wing is you have air coming in like this, and as the air is forced up over this little hump right here, and then it comes down here, it creates a pressure less than atmospheric up here. Atmospheric pressure then ends up pushing up like this, and that's what gives the airplane lift. That's what lifts it up in the air. So as you force it through the air like this at a high rate of speed, the air going across the top creates a low pressure area, and it just kind of sucks the airplane up in the air. The atmospheric pressure actually pushes it up in the air. So if we turn that this way, same thing's happening over here with the venturi in the carburetor or the throttle body or the air horn or whatever. As air's coming through here, as it passes through this little hump right here, it's going to accelerate that air. It's going to create a pressure less than atmospheric. And so with the valve closed, so what we're going to do is we're going to restrict the amount of air that's coming into the venturi by closing the throttle plate. So by restricting the amount of air that's coming down here, what we're going to do is we're going to create a pressure less than atmospheric right here. And so this is right here, this is manifold vacuum. And so this right here will actually be drawing air this direction here. And so that way you feel the sucking motion whenever you unplug a vacuum hose and stick your finger on it. That's vacuum. Now that's manifold vacuum. So let's talk about what port vacuum is. Port vacuum is if you had a vacuum hose up here above the throttle plate. So when the throttle plate's closed like this, the air comes in like this, and it can't really go anywhere. It just kind of bunches up right there. So there's not really anything going on right there. So you won't have any vacuum at all. This will just be stale. So you won't have any suction, you won't have any pressure. It's just there. And so that's with the throttle plates closed. Now as soon as we open up the throttle plates, let's make sure they're open. Okay, now what we have is we have the air rushing past here. The air equalizes down here, so we no longer have vacuum on this portion of it. So that's really kind of, there's no suction, there's no pressure there. But we have a lot of air rushing past here, so we have a suction force going that direction here. So basically, bottom line is, when the throttle plates are open, you have vacuum at ported vacuum. When the throttle plates are closed, you have vacuum at manifold vacuum. So this right here would be port. So this is open, and this right here is throttle closed. Okay, so when you're looking for vacuum sources, keep that in mind. Ported vacuum is going to be with the throttle open, manifold vacuum is going to be with the throttle closed. With the vacuum test that it covers in your textbook, we're dealing with manifold vacuum.